Welcome to a new RKB Bearing Industries educational video, where we deal with the importance of selecting and using proper steel in manufacturing high-quality and reliable bearings according to the highest international standards. High-carbon steel is the most used material for standard rolling bearings. In order to be used, the alloy steel has to pass through a series of elaboration processes such as electric furnace melting, furnace refining and degassing, continuous casting, heating and refining, hot rolling, and annealing. Before being used as bearing material, the steel bars are inspected by means of non-destructive tests. This method is commonly used for bearing steel because it has a lower capital cost. However, its low cost is paid with some important issues concerning segregation rate, shrinkage defects, steel oxidation, non-metallic inclusions, and material impurities. Anyway, there is another method to obtain bearing steel by means of a more technological process compared to the standard one. It is called vacuum degassed electroslag remelting. Hydrogen elimination, non-metallic refinement, fine grain structure, near absence of shrinkage defects, and low segregation rate represent the main advantages of the RKB Type.RAV steel, that is the special RKB bearing steel obtained through the vacuum degassed electroslag remelting process. All these qualities make RKB Type.RAV a proper substitute for case-hardened steel in critical and severe applications. As will be explained in detail in this educational video, the benefits offered by the RKB Type.RAV steel to our bearings are evident in terms of heat treatments, fine grinding and inspection processes, wear and corrosion resistance, mounting operations, basic rating life, and life cycle costs. Having a proper chemical composition and fine grain structure, the RKB Type.RAV steel capitalizes on special heat treatments to reach a proper hardness, 58 to 63 HRC, useful for wear resistance and dimensional stability. In this movie clip, you can see a phase of the temperability process in our RKB T3 manufacturing plant. By adopting the RKB Type.RAV steel, there are relevant advantages in the temperability property during heat treatment operations, and in particular in performing the isothermal bainite treatment. One of the major disadvantages of using standard steel is evident during the fine grinding process. In fact, in this phase, the softer steel matrix surrounding the hard brittle non-metallic inclusions is partly removed. The removal of the inclusions from the steel surface forms a void cavity or a pit. With time, during bearing functioning, this void can react as a micro-crack initiator that finally may lead to the total bearing failure. On the other hand, the RKB Type.RAV steel has a high cleanliness as regards non-metallic inclusions, which decreases the possibility that during the fine grinding process void cavities form. Moreover, if the fine grinding process is carried out incorrectly, for example without an adequate cooling system, there is a high risk of metallurgical transformations in the material structure, which can lead to quality loss of mechanical properties, particularly in the ribs, where the surfaces are small and cannot dissipate the heat generated in this phase. As this movie clearly shows, RKB performs the fine grinding process in a proper manner. In this way, we avoid temperature rising during the manufacturing process, eliminating the possibility of metallurgical transformations in the material structure. MPI, or magnetic particle inspection, is just one of the many inspection methods used by the RKB Group to check product quality. These two schematic drawings represent the principles of magnetic particle inspection depending on microcrack type, superficial or beneath surface. In this movie clip, you can see the application of the magnetic particle inspection to one of our products in RKB T3 manufacturing plant. In this way, we guarantee our bearings premium reliability. Our bearings, made of RKB Type.RAV steel, are less susceptible to contaminants, meaning that the indentations caused by foreign solid particles do not cause premature fatigue damage to our bearings. Thanks to the wear resistance offered by our special bearing steel, any bearing damage would spread 4 times slower than in bearings made of standard steel. The high corrosion resistance of the RKB Type.RAV steel was proved in a sodium chloride solution immersion test. As it can be easily noticed, there is excessive rust on the standard bearing steel surface compared with the RKB Type.RAV steel sample. In fact, standard bearing steel contains coarse eutectic carbides that act as crack initiators and reduce chromium content in the martensite matrix. On the contrary, the RKB Type.RAV steel has no eutectic carbides, but consists of fine dispersed carbides and strong martensite that improve resistance to corrosion. The use of the RKB Type.RAV steel makes mounting damages less likely to occur. The extreme heat generated during the mounting process does not affect the RKB special bearing steel thanks to the more stable structure of this alloy. In addition, in case of excessive loads, the chance of bearing damage is very low because the RKB Type.RAV steel has a very fine grain size, which increases material strength. Finally, by using the RKB special bearing steel, the possibility of damaging the bearing during the common mounting operations is lower thanks to its overall better mechanical properties. In order to verify the quality of our bearing steel, we performed a counter-fatigue life test. We selected 5 leading steel suppliers, and on one of them we imposed to respect our JXBOX series bearing steel protocol for premium reliability in critical severe applications, equivalent to grade 6 and grade 7. The material samples were annealed and manufactured in washer samples, hardened in a gas-protected electro-furnace between 835 and 845 centigrades for 50 minutes, and finally tempered between 150 and 160 centigrades for 3 hours. The evaluation was performed in a test life prediction tester with a maximum contact stress of 4,508 megapascals and 2,040 revolutions per minute. The results were as expected. The RKB Type.RAV premium class bearing steel, in compliance with our high quality standards, is clearly superior to the other materials. As is evident from this graph, the washer samples made of our steel present the highest values of rating life and average life. At RKB, by means of our special bearing steel, we are pursuing the goal of developing individual problem solutions for customers in a large variety of applications, especially where the previously used rolling bearing materials have reached their limits, standard bearings must be replaced quite frequently, and the downtimes of entire systems, including the cost system, are to be reduced. As you can see from this illustration, comparing the investment and capital costs for our bearings and standard bearings, our costs are a little bit higher. However, they are soon recovered in terms of operating and maintenance costs. Therefore, thanks to the reliability of our bearings, provided by the cleanliness and the manufacturing quality of our steel, our clients get an economic profit. Our provider of superior quality steel, obtained through the vacuum degas electroslag remelting process, has to respect the RKB JXBOX series protocol. This protocol specifies the main issues of high carbon chromium steel for rolling bearings, such as dimensions, shape, chemical composition, hardness, carbide size and network eligibility, non-metallic inclusions, check methods, regulations for inspection and packaging.
We find ourselves in the chemical and metallographic laboratories of RKB Bearing Industries in Balerna, Switzerland, to test the materials we use to manufacture our bearings. ARL446 is a multi-channel optical emission spectrometer that helps us determine the chemical composition of our bearing steel. After cutting and polishing the metallic sample, we apply to it a high voltage spark for 3 times as required by the proper test procedure. The results of this evaluation, displayed on the PC monitor, are finally checked and compared with the technical specification RKB material guidelines JXBOX series. In order to evaluate the material samples from a metallographic point of view, we perform ordered grinding operations with abrasive tapes from 150 grids to 1000 grids. proper evaluation of the material microstructure, first of all we need to use etchant substances, in particular 2% concentration metal, to eliminate Bale layer, that is the bright layer on the metallic surface. Finally, we analyze the metallic sample under an MC2 metallographic microscope. In this way, the material microstructure can be easily observed and non-metallic inclusions and carbides can be evaluated in a proper manner. For this test, we follow the international standards ASTM E45 for non-metallic inclusions and ISO 5949 for carbide size and networks.
In order to make clear the differences between standard bearing steel and RKB Type.RAV special bearing steel, we evaluated them from a metallographic point of view. We investigated an area of approximately 112 square millimeters for no-metallic inclusions according to ASTM E3 and ASTM E45, and an area of approximately 95 square millimeters for carbide size and networks according to ISO 5949. As you can easily see from these two pictures, standard steel has more and bigger globular oxides than RKB steel has. As carbide networks are regarded, a huge difference can be observed in these two photographs. Carbides can act as initiation sites for cracking and crack propagation. Moreover, if carbides form networks during the steel elaboration process, a bearing failure is likely to occur. As these pictures show, in the case of standard steel, the carbides form the networks, while in the case of RKB Type.RAV steel, they are smaller and uniformly distributed in the whole area. Finally, as for the evaluation of no-metallic inclusions, we examined their total number and total length. This bar graph says that the total number of oxides, oxysulfides, sulfides and titanium oxides, both small size 1 to 10 micrometers and big size 10 to 40 micrometers, is much higher in standard steel than in our special bearing steel. The evaluation of the total length of non-metallic inclusions consisted in a transversal and longitudinal section inspection. As you can see, in both sections, the total length turns out to be much higher in standard steel than in RKB Type.RAV steel. Summarizing, the RKB Type.RAV special bearing steel ensures better temperability properties, better mechanical properties, higher cleanliness, and higher wear and corrosion resistance. All these qualities lead to the higher reliability and performance of our rolling bearings. The RKB Type.RAV steel is particularly suitable for bearings used in applications such as wind turbines, power transmission equipments, crushers, marine offshore systems, and more.